Hello everyone. In this video we'll do some examples for circular permutations. One thing that you need to recall is that the number of circular permutations of n different objects is equal to number of linear permutations of the same objects divided by n. So that will be n factorial divided by n, which is the formula, the closed formula is n minus 1 factorial. Okay, let's see the example. Hilbert called for a hiring committee meeting with the members Bernard, Henry, Emmy, Sophie, and Herman. The meeting room has a round table. In how many different ways can Hilbert and his colleague sit at the table? Okay, so this is exactly the case. The number of people there, the number of objects or people is equal to, well, Hilbert 2, 3, 4, 5, 6 is 6. Now, number of circular permutations, which is the number of ways they can sit at the round table, is 6 minus 1 factorial, which is just 5 factorial. Okay. What if, in how many ways Hilbert and his colleagues sit at the table if Emmy and Sophie wants to sit next to each other? So what should we do here? Sitting next to each other, remember the trick we had. So we use the grouping trick. So what do? We group Emmy and Sophie and form one group of 2, yes? So this way now we have Hilbert, Herman, Henry, and Bernard, and the group of G, the E and S, yes, together. Now we first put these guys 1, 2, 3, 4, 5 objects. So the first is that form the group, form the circle using 5. Yes, 4 of the other members and plus the group, which we consider as one person, of 2. So this will give me 5 minus 1 factorial, which is just 4 factorial. But that is just step 1. Step 2 is that, okay, now that let's go to that group. Is Amy going to sit to the left of Sophie or to the right? So that is the second step. 2 is fix the order of E and S. Here, since E and S are going to, although they're sitting at circle, but they're not forming a circle, they are going to be next to each other. So they are going to form a line of 2. Yes. So and we know that number of permutations for 2 objects in a line is 2 factorial. Okay, so there's other way of counting that. You either do ES or SE. Yes, there are 2 cases. So now the total number is going to be 4 factorial times 2 factorial, which is 4 factorial is 24, 2 factorial is 2. There are 48 ways to do this one. Okay. let's see, in how many different ways can Hilbert and his colleagues sit at if Amy and Sophie does not want to be next to each other? Okay, so here then you see there in the previous example we put them together next to each other, but now we want to exclude that, so we need to use complement trick. How does it work? The number of cases that E and S are not together is equal to number of all possible ways. So this is NU minus number of cases. So I can now do this one. Number of cases that E and S are next to each other. Okay, so the number of ways that we NU is that, just consider no condition. We have 6 people around the sitting at the table. So the number of ways will be equal to number of all possible ways to do this, which is 6 minus 1 factorial. Minus the number of ways we can do this other one, which is next to each other. We found that it's going to be 48. So this is 5 factorial minus 48. 5 factorial is 120 minus 48. That will give me 72. Yes, I guess. So there are 72 cases in which Emmy and Sophie won't be next to each other. Okay. In how many different ways can Hilbert and his colleagues sit at the table if Emmy wants to sit opposite to Hilbert's chair? So Hilbert, wherever Hilbert sits, we want Emmy to be opposite on the opposite chair. Okay. So what do we do in this case? So this is a trick that you have to keep in mind. So what we do is that first form a circle without Emmy. Means what? We put aside Emmy. There are 5 total. So this way we have 5 total people minus 1 because it's circular factorial. Then just bring in a chair and add to the circle. There's only one place opposite to Hilbert's chair. Yes. So then add a chair to the table opposite to Hilbert's and ask Emmy to sit there. Okay, how many ways this is possible? You see, Hilbert is known in somewhere, yes, the others are I don't know where. Now there is only one way to fix that opposite, and Amy is going to sit there. There's no other possibilities. So that means that we have only one possibility for that. Okay, now by the fundamental counting principle, so the total number of the ways is going to be 4 factorial, which is what we found there, times 1, and that will give us 24 cases. Okay. And the last one, in how many different ways Hilbert and his colleagues can sit at the table? If Hilbert chooses to sit at a chair that he sat at last meeting. Okay, so we fix a chair that Hilbert sits there. Then the rest, now we have to decide, yes. Well, when Hilbert sits at a chair, basically he fixes beginning and end of a line. Yes, so now we can always start from the left of Hilbert and ask everyone to sit as if they are sitting in a line. So fixing Hilbert's place indeed makes our circle, basically breaks the symmetry of the circle and makes it into line. So number of ways to do it is equal to number of lines, number of ways that people can sit at a line. Lines formed by 5 colleagues of Hilbert. And you know how many there are because there are 5 and then in the line. In other words, well, if you fix Hilbert, there will be 5 possibilities for the next person in his left, then 4 person to the next one, third and 2 and 1. There's no symmetry here. There's no rotating. Hilbert is fixed, sit in one place. So that means that we are dealing with a 5 factorial. Okay, which is 120 cases. Okay. So these were examples of circular permutations sitting at a meeting round table.